we're going to multiply two binomials using an area model. So this is the activity called multiplication as an area model part 2. Okay, and so what we're trying to do is we're trying to multiply 2x, so 2 x's in a row and 2 1s multiplied by each other. Notice that if you click on them once, they'll turn positive to negative, or if you double click on them, they will rotate. Okay, and then times x plus 1. And what I am interested in is finding the area that is created if I take this length and width here. So x times x is x squared, and x times x is x squared again. X times 1 is 1x. X times 1 is 1x. More 1x's, more 1x's, and then 2 little 1s here. Okay, so you can also drag and highlight to kind of move whole things. So when I multiply x plus 1 times 2x plus 2, I'm going to get x squared, 2x squared, right? There's 2 of them, so 2x squared plus 1, 2, 3, 4x plus 1, 2. So 2x squared plus 4x plus 2 is what's happened when I get x plus 1 times 2x plus 2. What I would like you all to do right now is pause the video and go ahead and try the second one off on the right, 3x minus 2 times 2x plus 1. Alright, so I'm assuming that you've already paused the video and tried this one on your own, and your result should have been 6x squared minus x minus 2. Now let's talk about why minus x, right? At some point I should have got 3 x's. So I should, at some point in my diagram, I would have had like 3 x's. I think they would have been like this. And then you would have had 4 negative x's, right? And they would have been like this. And I'll switch those to negative. So why is it negative 1x? Well, that is a good question. So, when I created my diagram here, I had, I'm forgetting about the 6x squareds that are here and your minus 2's that are down here. When I have this created, I have 4 negative x's here and 3 positive x's. Each one of these at negative x's pairs up with a positive x. And then what happens is these all cancel out to 0. So everything on this column here is canceled out to 0, leaving just 1 negative x left over. So again, that's why the second problem is 6x squared minus x minus 2. Okay, so what we're going to do now is we are going to go backwards. So now we're at the next section that says find the factors of the quadratic equation when the a value is not equal to 1. So again, just like what we had previously done, we want to try to find all of our parts that we have. So I need 4x squareds. Okay, so 4x squareds. Okay, and then I need 8 x's. So 1, 2, 3, 4, 5, 6, 7, 8. And then 3 little positives. Okay, 1, 2. Okay. And with all this material, basically what I'm trying to do is I'm trying to build a perfect rectangle. Again, when I'm building my rectangle here, I want to try my best to keep my x squareds in the upper left hand corner and my 1's in the bottom right hand. Okay, so let's try to do this on our own here. So as I'm looking through this, I want to arrange my my x squareds first. And there's a couple different ways. I can arrange them in a 2 by 2, or I can arrange them in a 4 by 1. And it doesn't, there's only one way that's going to be right, so we just kind of have to try it. So let's just try and put it in a 2 by 2. Okay. So then I need to try to fit my x's here in the best possible way. Okay, so let's just try to kind of split them up evenly. I'm going to go ahead and do this. Oh, I wish it would have got all of them, no big deal. So it looks like I can reasonably put all of them here to kind of create my rectangle. But it looks like I'm kind of having a little bit of a problem because looks like I'm just 1 unit short of actually making a rectangle. Although this is close, this has a gap in it and is not a rectangle. So we can do some things, we can shuffle some things around. For example, if I wanted to, I could try to, I could put my x's here and then try to redistribute my x's here. So maybe I can do this, Then again, I can already see I'm gonna run out of space. Like the way I have this currently set up is I don't have room for these ones. Okay, so what I would like you to do right now is just pause the video and see if you can rearrange these in an order that you think will get yourself a rectangle. Okay, so I'm assuming you've already paused the video and now we're kind of trying to see what we got here. So I'm just going to put these back kind of how they were. Okay, I'm going to have to switch all of these around. Alright, so I noticed when I was here that I was just 1 unit short of getting all these pieces together, right? But, I thought, what if I take this row out and put it up here? What happens? I end up getting just enough space to make my rectangle. Okay, so let's think about what my answer is now, because I did create a rectangle. So that means I can now find its length and width. Okay, so let's think about all these boxes are X area. The width here is only 1 unit, right? So if we see here to here, it's only 1 unit. So this is 1, 2, 3, and then this here has a length of what? This whole area is x squared, but this length here is x. So I have x plus x, so 2x here, and then plus 3. So there's my first factor, 2x plus 3. All right, and then here I have x, and then length of 1. So 2x plus 1. Okay, so that's how we factored it, right? 2x plus 3 times 2x plus 1. Okay, let's move on to the last one. The last one has 2x squared plus a positive x, and then minus 3. All right. So this one is quite complicated, right? There's only one way I can organize two things as a 2 by 1, so I don't really have any other option but to put the x here. But no matter what I do, these little ones just aren't going to fit. So this poses a little bit of a problem, okay? So when you have an issue like this, we now need to introduce what I would call a sneaky zero. So if I bring in a positive x and a negative x, oops. So if I bring in this, that's technically the value of 0. So I'm really not changing the value. I'm just introducing 0 into the problem to try to create a more laid out version here that will give us a little bit more to work with. Okay, so let's go ahead and do this. What if I put my x's down here? Okay, and my negative 1 here. Okay, and then I can start fitting in my negative 1s. Although this helped, it didn't quite give me the answer I was hoping to get, because I still have 2 negatives here. So knowing that, I'm going to go ahead. I'm going to introduce another sneaky 1. Okay, so here, and then we can kind of. Okay, but then again here, I'm just kind of out of space. So here, I just don't really have much to work with. But what if I went and, see, I have 3 here and I have 2 here. So what if I did something like this? What if I brought these negatives down here and these positives up here? Okay, this will allow me to, be a little bit more flexible. Okay, and then these all have to flip. All right. And so now I have created a rectangle successfully. Let's find our area. Our area is right here. And again, I did not change the area value at all. I still have x squared plus 1x and minus 3, because each of these positive and negative x's cancel each other out exactly 1 time. Okay, so let's go ahead and look. I have length x and then length -1. So this here is x minus 1. I'm going to write that down. Alright, and then here I have x and then another x, so this is 2x, and then 3. 1, 2, 3. So this is 2x plus 3 because those are all positive here. Okay, so that is kind of the gist of it. This is a method of factoring that's pretty fail-safe here. And there's only one thing that I want you to be able to answer for me here, and it's really at the bottom. Okay, so when we are factoring quadratics where the a value is not 1, so if you look at your worksheet, we have 4x squared plus 8x plus 3. That 4, okay, in the past for us that's always been 1, and today it's not 1. And if you look at the next one on the right, that a value is also not 1. So I want you to be able to answer this question. Can we factor quadratics such as the ones that we just did by simply finding the numbers that multiply to the c value and add to the b value? Why or why not? So I'm going to give my best representation to that here in a moment, but then I would like you to think about that on your own first, so pause the video and think. Okay, so I'm assuming we've already paused the video, and here's essentially the reason why. The reason why is when that a value is 1, right? When my a value is 1, like it doesn't matter what else is going on. When I have one x squared tile, there's only one way for me to rearrange that 1x squared tile. It's a 1 by 1. But the problem is when I start getting like 2 or 3, or more than 1. Let's say I have 4. When I'm looking at these x squared tiles, there's more than one way to rearrange them. I can rearrange them into a 2x or a 2 by 2 or a 4 by 1. Okay, and then even to elaborate on that more, even when I have a 2x's here, right? Even when I have 2x's, especially when it's negative, I have to struggle to think about where my positive x's are going and where my negative x's are going. So it's kind of like a rearranging issue that we have. Okay, so the tiles are definitely a method that I would encourage you to use. They are a little bit slower than the algebraic ones that I will be teaching eventually, but they're pretty fail-safe. So that's the end of this video, and I will see you at the beginning of the 4.2 notes.